Hello, this is Neil Feit from the Fredonia Department of Philosophy. In this video, I'm going to be talking about the logic of relations, relational predicate logic, and going to symbolize a few sentences from English into relational predicate logic, and then I'm just going to do a few Power of Logic web tutor exercises for those of you out there who are using the Power of Logic textbook or the web tutor site for the Power of Logic. You see on the left here that we have a few monadic statement functions or propositional functions, or the uppercase letters are predicates. So let's let CX mean that X is a national capital. Okay, so that's true of places like Washington, D.C. and London and so forth. And let's let TX mean that X is a tourist. Here in the middle we have one relational two-place function. VXY will mean that X has visited Y, and here on the right we have a couple of names or individual constants. Let A be the name for Alice and W be the name for the city, Washington, D.C. Okay, so I'm going to take a look at this first sentence here under the line. Alice has visited Washington, D.C. Okay, this statement involves no quantification. You don't need an existential or a universal quantifier. You really shouldn't have one there. It's what we're going to call an atomic or singular statement, a singular atomic statement. This statement is directly about Alice and Washington, D.C., so it says that the first, Alice, has visited the second, Washington, D.C. That's how I would symbolize that statement, V-A-W. The second statement here, Alice has visited some national capitals, and we're going to treat that as saying that Alice has visited at least one national capital. Okay, I'm not here dealing with the logic of identity. We would need the identity, the equal sign, to say that she has visited, for example, at least two national capitals. So let's just take that statement to be true, provided that Alice has visited at least one national capital. The logical form of that statement is something like this. There exists a national capital that Alice has visited. So there exists some object, call it X, such that X is a national capital and Alice has visited X. And that's exactly what I'm going to write. There exists an X such that I need to open a parenthesis there because I now want to say something that involves a compound formula that has to do with X. I want to say that X is both a national capital, which I'm calling CX, and, conjunction, I want to say also that Alice has visited this city, so VAX. Okay, I would read that back into English as, excuse me. There exists an X, or for some X, X is a national capital, and Alice has visited X. Okay. Don't be concerned that there's an X here and there's a Y here. The second place here, the Y place, is simply the place that has been visited. And in this case, that's the city that we're quantifying over with the variable X. Okay, the next series of statements, I'm going to look down at the one where the cursor is flashing, don't talk about Alice. In fact, they don't talk about any person, place, or thing by name. They're purely quantificational, quantifier statements. So some tourists have visited some national capitals. The logical form of that is something like this. And by the way, I encourage you, if you'd like, to pause the video and try to symbolize that statement given the scheme of abbreviation up on top of the screen above the line. Basically says that there's a tourist. There exists an X who's a tourist, and this X, this tourist, has visited some national capital. So there's a national capital, a Y, such that the tourist has visited Y. So I'm going to start out with my existential quantifier. There exists an X. What about this X? Well, X is a tourist. And now I want to say that this tourist, X, has visited some national capitals. To be an X who has visited some national capitals is for there to exist a Y such that Y is a national capital and X has visited Y. And I'm going to close two parentheses, the one that I opened before the CY, because the cy.vxy is a compound formula, and but the one that I opened there, I'm going to close there. Okay. In general, it's good to make sure that you have an equal number of open parentheses and closed parentheses. So I would read this back into English as follows. There exists an X such that X is a tourist, and there exists a Y such that Y is a national capital, and X has visited Y. And that seems to capture what's being claimed in that English statement. Okay. The next statement, some tourists have visited every national capital, starts out in a similar way. There exists an X such that X is a tourist, but now we want to say that this X, this tourist, has visited every national capital. And what is it to be an X who has visited every national capital? Well, it's to be such that for all Y, if Y is a national capital, and we do need a conditional there, then X has visited Y. So the lower formula says that some tourist has visited every national capital. In other words, there's an X who's a tourist, and this X has visited every national capital. The upper one says that the tourist has visited some, that is, at least one national capital. Okay. What about the third one down? No tourist has visited every national capital. Well, that is simply the negation, the denial of the statement above it. To say that no tourist has visited every national capital is to deny that some tourist has, or that some tourists have. Okay, so I'm going to take it easy on myself here. I'm going to copy that. I'm going to paste it here. And I'm just going to say that it's not the case, not. Okay. Well, if I really wanted to, I could say that a different way. I could say something like, for every tourist, and a negative existential statement like this is always equivalent to a universal statement. For every tourist, I might say something like, by the way, I could just put the tilde in front of this formula, and that would be right. Or I could say, for every tourist, there's a national capital that the tourist hasn't visited. So for every tourist, there exists a Y such that Y is a national capital, and it's not the case that X has visited Y. Okay, and those two statements are logically equivalent, and both would be correct ways of symbolizing that English statement, no tourist has visited every national capital. This says, for every tourist, there's a national capital that the tourist hasn't visited. Okay, notice that in all of these cases I have a new variable, a Y, when I need to start talking about a new thing, namely a national capital. And it needs to be a different variable than the X, because it's within the scope of the X. The scope of this existential, for example, up here, the scope of that existential quantifier goes all the way to the end of the statement, and so we need a new variable, for example, Y, when we want to introduce a quantifier over a new item, such as something that might be a national capital. Okay. I'm going to do the next one rather quickly. Every tourist has visited some national capital is very similar to this first one, except it's a universal rather than an existential claim. Basically, this has a logical form, something like this. For all X, if X is a tourist, then there exists a national capital, there exists a Y, which is a national capital that X has visited. So this is about every tourist, so I would say for all X, if X is a tourist, then there exists a Y such that Y is a national capital, and X, the tourist, has visited Y, the capital. I don't know if I need to keep the scheme of abbreviation up here, but I think we've been using the predicates enough now that it should be before your mind. Now, what about the next one? Some tourists have visited no national capitals. Well, that's an existential statement. It says there exists an X who's a tourist. And what about this X? Well, we want to say that there does not exist a national capital that this tourist has visited. And it's very important to have a tilde and then an existential quantifier, in this case existential y. So we're saying for this tourist X, there does not exist a national capital that the tourist has visited. So it's not the case that there exists a y such that y is a national capital and X has visited y. Okay. If we wanted to say that in a slightly different way, we could start off similarly. There exists an X such that X is a tourist, and I could also say something like this. Every national capital has not been visited by X. So for all y, if here, since we're dealing with a universal, if y is a national capital, then it's not the case that X has visited y. Those two statements, the two bottommost statements that you see, are logically equivalent and both good ways of symbolizing that English statement. Some tourists have visited no national capitals. By the way, here's a way not to symbolize that statement. You don't want to say that there exists an X such that X is a tourist, and, for example, there's a city, there exists a Y, a capital city, that has not been visited by X. Okay. This is a perfectly good formula of first-order logic, relational predicate logic, but it doesn't say that some tourists have visited no national capitals. What does it say? Well, it says, excuse me. Let me try to get that back. It says that there's a tourist and that there's a capital, and I forgot to put in a dot there, a capital that they haven't visited. This basically says for some tourist there is a national capital that the tourist hasn't visited. Or in other words, let me get my cursor back. There does need to be a dot there, and I apologize. Okay. What does that statement say? The one that I just wrote was not the right symbolization for this statement up here. Well, it says something like this. Some tourist, let's see, has a city that he or she hasn't visited. So basically it says some tourist has not visited every national capital. All of a sudden I can't type, but that's basically what it says. So if you want to know what that kind of statement would express in English, it says something like some tourist has not visited every national capital, or for some tourist there exists a capital city that they haven't visited. Okay, here's one more challenging one, relatively challenging one, and after I do this one I'm going to maybe talk about a couple of WebTutor, Power of Logic WebTutor examples on this type of skill, but only just a couple. Okay, some tourist has visited every national capital that Alice has visited. Well, this is an existential statement. It says that there exists a tourist. Okay, well, what about this X who has a tourist? Well, this tourist has visited every national capital that Alice has visited. Okay, what is it to have visited? Well, it's for all Y. Now, I want to say something like, if Y is a national capital that Alice has visited. So I'm going to have an arrow here as my main operator relative to that universal Y, but I'm going to have a compound antecedent here. So for all Y, I want to say if Y is a national capital and Alice has visited Y, so VAY, then here's where I have my arrow. Well, now I'm still talking about that X. The idea here is for all Y, if Y is a capital and Alice has visited Y, then this tourist X has also visited Y. So VY. xy. Okay, I just closed the parenthesis that I opened after the universal quantifier y, and I have to also close the parenthesis that I opened after the existential x, and I think that's right. There exists an x who is a tourist, and for all y, if y is a national capital and Alice has visited there, then x, our tourist, has visited it also. Okay, and I've opened one parenthesis, and I've opened 2, 3, and I've closed 1, 2, 3. That looks okay. Okay. I'm going to go over here to the Power of Logic web tutor for just a second. I'm going to, here on Chapter 9, I'm going to select, I want to keep this video shorter than 20 minutes, so I'm just going to maybe do 9.5b. Maybe I'll do number 4. Yeah, I'll do number 4. Some financier is richer than everyone. Okay, maybe I will make that a little bit bigger. Okay. Here we have that fx means that x is a financier, rxy, x is richer than y, px is x is a person, so we're supposed to treat this as saying that some financier is richer than every person. Okay, so it's existential. That has wide scope. There exists an x. Well, what about this x? X is a financier. And now I want to say that x is richer than every person. So now I need a universal y for all y. And here I want to say if y is a person, because it doesn't say he's richer than monkeys, for example. You know there are these rich monkeys around. Then if y is a person, then our financier x is richer, rxy. Okay? So that's an example that has a form similar to one of the ones that I was doing before, and it says that I'm correct. This does, by the way, entail that this financier is richer than herself, for example. But we can't say that some financier is richer than every other person or financier, for example, unless we have use of the identity sign, which is the subject of another video or perhaps a topic another day. I'm going to go do maybe just one more before I end this. I'm going to go over to 9.5d, and I'll do number 14. Okay. No logician argues about every subject with everyone. Okay. Here we have, for example, a three-place triadic propositional function or statement function, and A is a three-place predicate. It means AXYZ means X argues about Y with Z. So Y here, that the middle place, is the topic or subject about which the two end places are arguing. Okay, so this, it might help some of you to think of this as the negation of some logician argues about every subject with everyone. So in fact, maybe I'll treat it that way. I'm going to say some logician. So there exists an X. Oops, excuse me. Wrong field there. There exists an X. And I want to say X is a logician X. And now I want to say that this logician argues about every subject with everyone. So I would say something like for all Y. If Y is a subject, so SY arrow, oops, excuse me. If Y is a subject, then we want for there to be with everyone. So I have to have another variable here for all Z. If Z is a person, and what I'm doing here is I'm using a new variable when I need to talk about a new person. Here I've already said for every subject, but I need a person about whom this logician is arguing this subject, with whom this logician is arguing. So only when I want to start talking about this person do I want to introduce a new variable here. In this case, it strictly would be okay if I had the for all z right next to the for all y, but we need to change some things up, and in general, that's not a good way to put all your quantifiers towards the beginning. Okay, so there is a logician, and for all subjects, for all things y, if it's a subject, then for all things z, if z is a person, I want to say that x argues about y with z. Okay, and I closed the one before the z. Now I'm going to close the open parenthesis before the, after the z and after the y, and also the one after the original existential quantify. So 3 open, 3 close. But again, I want to say here that no logician, so that's just going back, and I'm going to negate that. Okay, that's correct. One good thing about the web tutor is that it is very good at recognizing logically equivalent formulas. So another way to say this is that remember we can think of a negative existential claim as a universal claim for all x. If x is a logician, then now the idea here we want to say it's not the case that this logician argues about every subject with everyone. So it's not the case that for all y, if y is a subject, then for all z, if z is a person, then x argues about y with z. Close, close, close. So this says, in effect, for every logician, it's not the case that for every subject and person that this logician argues about that subject with that person. Okay, and that's also correct. So I hope this video turns out to be useful to you. Signing off for now.